Hello everyone and welcome to today's session. So today's topic is Java miscellaneous topics, and the agenda for this session is like we are going to cover types of classes in Java, immutable classes, how to create immutable class, immutable list, comparable and comparator for sorting. So can anyone tell me like what are the different types of classes in Java? Like people from Java background, like what are the different types of classes that you can create in Java? Anyone? So you all have received these slides, right? So I've not put all the types of classes and all, but I've just put the rules for a few of the types of classes, like for static classes, what are the rules? So like, can anyone tell me like what are the other classes? Like static class is one kind of a class. If no one has idea, so I'll proceed.
I mean,
This
in
class,
what terms are like static, inner,
POJO classes,
immutable?
Yes. Yes, nested classes, static inner classes and inner classes, they are nested classes. Correct. So I want others also to, communicate and ask their doubts. You can ask anything you want. Don't worry about anything else. Okay. So let's get started with types of classes in Java. So here I've created a package which is types of classes. Let's begin with static class. So this is an static inner class, or we can call it a nested class, which is a static class over here. So this is your parent class. The name of the class is a static class example. It has a static member variable str, and the value is learning about how to access static inner class. All right. So one question to you guys: can I create a static outer class? Does Java
No,
support that? No,
no.
correct. So static classes will always be nested classes only. So this is a rule that you need to remember. Now, inside your static class, this is my static class, right? Public static class, static demo. So this static demo is my static class. And a static class is nothing but a nested class. Now, inside this static class, can I access a non-static outer class variable?
no,
No, right? So we can only access static variables. So you need to remember this. Inside static nested classes, you can only access static variables of outer class, but not the non-static variables of outer class. If I create here for others, just to show them, like if I create here, let's say this int a equals to 10. I cannot access this int a equal to 10 inside over here. Okay. If I try to access this, it will give me some compilation error, because see, you cannot access the non-static field inside the static inner class. So this is again a rule that you need to remember. So is this clear? So these rules are clear, right? I'll advise you to write down the rules, or because I have not mentioned, I think, all, or I've mentioned all. So see, the static class has only static members. It cannot access the non-static member of the outer class. We cannot create an object of the static class. We can create the instance of the outer class in some particular way, and that particular way is available in our code. So yeah, coming to the way how to create an object. So now at least this much is clear, right? Or if anyone has doubt, they can ask, then I'll proceed further, like how is this syntax and what is this syntax.
It's clear.
Okay, so here I've just created an instance of the static inner class. So you cannot directly create the object of the static inner class. So for that you have to write it in this way: outer class dot inner class reference is equal to new outer class dot inner class, and this is how you can create it. If I break it down, it will be like first I'm first, let's say if I want to break this syntax down, it will be like this. And using now again I'll need this, say this is 2, and using this I'll do this static demo, new static demo. All right, so new keyword cannot be used, so this has to be that way. But if it would be inner class, the syntax that I was trying to show you would work. But with the static inner class, it will not work. Why is that? Because this static demo is the static variable of this class. It's we can say the class level variable and not instance level variable. That is why it will not work. Okay, so this other approach you can use with the inner classes. So is this method of creating the object in a sense like of object of the static inner class clear, right? So you cannot directly create the object of static inner class. So this is how you have to create outer class dot static inner class reference equal to new object of the outer class dot the member of that class, which is the static demo. So this static class is nothing but a class level variable, or we can say not variable, class level member of the outer class. I know the words are a little complex, but this is how it is. That is why I wanted to have you black coffee and sit for today's session. These are the most complex topics. So this static member you have to declare in this way only: outer class dot static inner class object new static outer class dot the inner class. Okay, so if I run this, I'll get this string. So are you clear with the rules? Like in the static, so these static classes have to be nested classes, and we can call these static classes as class level members of the outer class. And the next rule is you cannot access the non-static variables inside the static inner class. So is these rules clear? Like what are the rules and how you can initialize kind of an object of inner class, but we cannot say it's an object of the inner class because inner class cannot be instantiated. This is like you are instantiating the outer class object, but in this particular way so that you can access the member method of the static inner class. This will go to that. Now final classes. So what happens like if you declare a class as final? Can anyone tell me?
Makes it immutable.
That is one thing. Immutability. Yeah, you cannot edit it. That is true.
You cannot instantiate it. You cannot get objects of it.
Cannot inherit from that class.
You cannot extend the class.
Yeah, you cannot extend the class. That's the main thing. If you create a class as final, it cannot be extended. That's the main thing. Okay. So over here, that's the thing. If I have a final class which prints this message, base class method is executed. And if I try to extend it, it will not allow me. Though this will not be. This will not work. See. So this is the thing that I wanted to show you. So this is about final class. We'll see more about immutability in this package when we go over here. That is also planned. So as far as the rules goes, so static rules are clear and final are also clear, cannot be extended. It also prevents the class from being subclass. So it's the same, right? It cannot be extended means it cannot be subclassed. Now abstract classes. So what are the rules for abstract class? We'll see that first and we'll move to code. So the class may or may not contain abstract methods. We can achieve data hiding by using abstract class. So example of that will be available in our code. We cannot create an instance of the abstract class, but it can be subclass. So these three rules are quite simple, right? Now let's see this in action. So this is our abstract class. Not that is not our abstract class, sorry. So this is mathematical operation is our abstract class, and we have hide these two variables a and b. Okay, this is our main class which is extending that abstract class, and we are providing the implementation for the add method. And when we call this add method in our main method, we are printing the sum of a and b. So these value of a and b is hidden over here. So it is coming from the abstract class. So this is how we have achieved data hiding. So you might be also aware of this overloading and overriding, right? So can you override a static method? A very famous interview question. If you go for any like this very senior level rounds, like can you override a static method?
No,
No,
No.
Why can you not override it? What's the reason? What happens?
they are based on the class implementation. If you extend
Yes,
and modify it, it will be inconsistent.
correct. So Java has made it that way. So static methods cannot be overridden. They are hidden. That is why in the extended class they are hidden because they are at the class level. Okay. So these two are the non-static methods, variables, right? A and B. A is 30, B is 40. So they are basically hidden when you extend this. So you can obviously access the value, but it is hidden at this level, right? It is hidden at this C abstract class example level. So you're directly adding the value. So this is how you can hide few values, and if someone wants to access it, they'll have to access it by extending and then then accessing your variables. So this is one thing. So what will be the output of this? Very simple, right? 30 plus 40, 70. Let's run this. All right, so here you can see the output. Sum of A and B is 70. So this abstract class is clear, right? So in abstract class, you can have abstract methods as well as concrete methods. I mean, if I want to add subtract over here and I want to provide implementation over here, can I provide that? Can I do this? Public int subtract.
Yes.
Yeah. All right. The next is very simple, concrete class example. So this is just your basic thing which you use day to day, your concrete classes. So here what I've done is this is our main method. Let me just format this. This is your main method. And here we have created one static method product which takes A and B and calculates the product. And here you're calling it and printing it. So I'll just quickly run it and move to next example. So this is also a type of a class that we use day to day, right? Concrete class. The doubt that he had the static class example. So here this was a little advanced topic. So what we had done is we had created a static inner class, because static classes can only be inner classes, or we can call nested classes. So this is our nested static class over here, and for creating the kind of an object, we cannot say directly the object of static inner class. You cannot create the object of static inner class. So kind of an object, we had used this kind of a syntax in which we were saying outer class dot static inner class reference equal to object of outer class dot reference, or we can say the kind of reference to the static inner class with this kind of a syntax, so that we can access this show method. And then I had shown you how you can access the like how you can practically use it by creating these static inner classes for your constants. So I'll proceed further. So we have cleared static, we have understood static classes, and then this we just see this, we created this class, another static class to see like we cannot access the private static nested classes. Then we have learned about final classes. Then we have learned about the abstract class example, and we have understood the difference between interface and abstract classes. Like, so the main difference was the access modifier. So in abstract class we can have protected, but in interface we cannot have that. So in interface you can create now from Java 8 concrete classes with help of default keyword and static keyword, but your visibility will always be public. You cannot have protected. Then concrete classes were straightforward. So someone had a question like, why are we creating a static method over here and accessing it from the main method? So the reason was so that we don't have to create object of the outer class. And I just showed you how you can create the object and access the product method in a non-static way. So you'll have to convert this from static method to a non-static method. So that part is also clear. If you want, I'll just write it and keep it for you. So let me just comment this out, and let me just So I've just written this out for you. Whoever had a doubt, now they can refer this. Okay. Now coming to singleton example, this is even more complex for few of, it might be even more complex for few of you. So we are not going to dive into all singleton design patterns over here. We'll dive into that in our upcoming sessions in design patterns. So currently here I've just demonstrated a lazy fetch method of singleton. So can anyone tell me what is like a singleton class? What is the meaning? What can you do with a
Only
singleton?
only one object that will be created out of that
Correct,
class.
correct. Only one object can be created. So how do you ensure that? You have to write this kind of a code for ensuring it. So let me give you a walkthrough of this singleton class. So here we have this object state, which is nothing but a variable of the singleton class. Okay, at a simple level, we can say it's a variable. We can assign any value to it. Then we are creating the instance, or we can say the reference of the singleton, and we are assigning it null initially. Then when we are initializing this class, so we are not going to initialize this singleton class with, let's say, singleton equal to new singleton. So this is a creational design pattern in Java. Okay, this is what you're seeing over here. So what does creational design patterns mean? It means like ways of instantiating your object. So the basic way is by using the new keyword. But when you're using that new keyword, you cannot limit the number of instances of your class that can be created, right? So let's say you want to limit the number of instances of the class that you can be created. Let's say for database connectivity, you want your application to achieve only one connection with your database. So you can achieve that by creating only one by implementing this singleton, and by ensuring that only one connection instance or one connection will be created with help of this class. Okay, so you will create your database connectivity class as your singleton class, so that only one connection can be established with the database. Basically only one object of the database connectivity class can be created. Okay, in simple words, if I say. So this is your singleton class, and the instance is equal to null. And in the constructor, you can say I'm just assigning value to this object state variable, and I'm assigning the value learning singleton lazy fetch method. So the other method is a eager fetch method, and currently here I've implemented the lazy fetch method. Okay, and if you're thinking about whether singleton can be broken by reflection, can be broken by multi-threading, can be broken by serialization, deserialization, reflection, all of these things, so that will be covered in your design pattern session, where I'll walk you through all different ways of breaking the singleton, and then the most robust way of creating singleton class in Java. All right. So coming to this simple example that we have over here, in which let's imagine we don't have all those things which will break our singleton. So this is our singleton, this constructor, where we are assigning this value learning singleton lazy fetch method to our object state variable. And then this is our static method get instance. Now using this get instance, we will create object of our singleton class. And how are we ensuring that only one object will be created of singleton class? So what we are doing is, first we are checking if the instance is equal to null. If it's equal to null, we are creating a new object with help of new keyword, and then we are returning this object. Now let's say at line number 7, if I again do this get instance, will it create another object and return me, or will it return me same object? Will it be like singleton 2 internally? Will it give me new object, or it will be same object?
It will be same object.
And why is that it will be same object?
We have provided a condition here, right?
Because the
Yeah,
You're
object
already
is
checking for the existing instance of the singleton class. So if it's existing, then you're returning the same instance.
correct, correct. So we are checking. So once we assign this instance equal to new singleton on line, so that happens when I call this get instance method on line number 5. Now it has already created the object. So now instance will not be equal to null. Now at line number 7, if I again do this get instance, it will come here and it will see the instance is not equal to null. So it will directly return the instance. Let me debug and show this for others who are new to Java world. So let's place this over here. Let's paste this over here. All right. So yeah, let me just remove this. Add. Java project. Okay. Miscellaneous. Okay. Okay. All right. So we have it. So I just had to link it. Let me take this above. Okay. So let me just actually my keyword shortcuts have that function keyword. I'll just go from here. Let's step into. So see, from line number 5, I've come over here to line number 20. It is checking if instance is equal to null, which it will be right now. So let's go to the next step. Screen is coming. Give me 2 minutes. Okay. So let's go to next step. Now we have come over here to the next line. Instance is equal to new singleton. So I'm creating an object of the singleton class. And then there is no exception. So I'm just returning this instance. So this instance is what now? Instance is equal to new singleton. So this is line number 5 that is being executed. Now here when we get this object store, it will print that the object, when we do this get object state, it will print the object state, the value, which is learning singleton lazy fetch method. So can anyone tell me why is this called lazy fetch method? Why is this lazy? What is the meaning of lazy over here?
Not sure, but in
So,
UI we have
I think it's loaded when you actually call the method.
Exactly. That
only
is why
when
it is lazy.
Yeah.
Yes, exactly. So when you're calling this get instance method, that time the object is getting created, right? So that is why it's called lazy. When your application starts, when it compiles, that time you're not creating the object. You're first, like in your get instance, you're creating the object. That is why this is called lazy fetch method, the lazy way of creating the singleton class. Okay, step over. Now when I come here, my object is already created. My singleton object was already created when I first called this get instance. So let me show you what happens. Now this instance is not equal to null. Okay. Now let me do get into. Now this will evaluate to false. So it will directly go to line number 27. See, and this is it. So this is how it is. So it is only creating one object, because once you call the get instance, it creates the object, and next time when you call the get instance, it returns the same object. So it does not create the new object of it. So this is how you ensure that only one object of your singleton class will be created by writing this kind of a code. Coming to POJO class. So POJO classes are very simple. So this is a POJO class where we have one variable price. This is the price 99.34. And here we have created the object of the POJO class and we are getting the price. So we have this one variable and the getter setter for this variable price. So this is the getter setters are also called mutators and accessors. So get are called accessors and set methods are also called mutators. Just another words. Okay. So in simple words, we can call the these are just terminologies in Java. Okay. Don't get confused. So these are also called the instance. See, this is not static variable, right? So this is called instance variable. And if it is a static keyword is over here, so this will be called class variable. So instance variable and class variable. Whatever is static is class variable. Whatever is not static is instance variable. So is this clear, the concept? Difference between class variable and instance variable?
Yes.
And if this method is static, what it will be? Class method, we can say, right? If we have static over here, it will be class method. And if we don't have static over here, it will be instance method. Okay, just a terminology. I mean, for you to remember, so that you don't get confused with the advanced concepts. So this is just a simple POJO class. So anyone has doubt about the simple POJO class? So moving to the inner class. So you have already understood the static nested class, right? Now this is also kind of a nested class, and this which is non-static class, so it is called inner class. Okay, simple, just different terminology. So this is a non-static inner class. This is your outer class, G inner class example. Just I've named it so that it will be in this order. That is why I put ABCD over here, so that it will be in same order, because Eclipse alphabetically like places it, right? All right. So this inner class, you can see in this this is not the inner class, it's the outer class, okay? Or just the example is of inner class. In this class, outer class, and the name of the outer class is just G underscore inner class example. We have one variable, private int variable, and the value is 10. We have one non-static method, create inner class, which basically creates the instance of the inner class, inner class in class equal to new inner class, and accesses its method access outer. So your this non-static inner classes can access your static as well as non-static outer class method. So here I have accessed the non-static outer class method. So can anyone tell me, like, if I create a static variable over here, let's say I create a private static int, let's say b is equal to 20. Can I access this b inside this access outer? I just gave you the answer some time back. Can I access this
No,
b?
you cannot.
Yes, sir.
Yes, you can access it.
Yes, we can access it, because the inner classes, non-static inner classes, has access to the static as well as non-static members of the outer class. In Java, in general, we can always access the static members and methods inside instance level things, right? Instance level classes, or this methods or variables, right? In Java, it is that way. Instance level methods or classes, I mean methods we can say, or objects we can say, can always have access to the static level variables or methods, but not the vice versa. In the static class, inner class, you cannot access the non-static we can say members. So we can say in this way, non-static members have access to both static and non-static members, but static members can have only access to other static members and not the other non-static members, in very simple way if I term it. So I can access this over here. I can write this out b. I can access it. Okay. See, I'm able to access it. But if it would be a static inner class, then can I access this private int?
No.
Yeah, because the non-static members cannot access the, I mean the static members cannot access the non-static members. Not just in inner class, in general in Java. So what is in general in Java also applies here in the inner classes. You can write these rules down and keep if you want. Or I'll just write it as a comment here. Static members can access only other static members. Okay. And
Can static inner classes have non-static methods as well?
can static inner classes, let's just see this is static inner class, can have,
Okay,
yeah,
yes.
it is, it
Yeah,
can, we have
non-static.
seen that. If this would be static, then we'll have to access it in the static way. This is called accessing a variable in a static way, right?
Yeah.
Okay. So a static member can access only other static members, whether it be of outer class or in general in Java. And non-static members can access both static and non-static other members. Okay, other non-static and non-static, or non-static is also called instance level. Okay, non-static is also called instance level members. Are we moving on to immutability? So this is an immutable class example. This is the main class. Let me open the student class. So this student class is an immutable class. Over here you can see we have three variables: name, which is a string; roll number, which is an integer; metadata, which is a map of string and string. Okay. Now here we have a constructor, and inside the constructor, can you observe something what we have implemented? What are we doing? When is the constructor called? Can anyone tell me that?
Whenever we will create an object,
New
We
so
need to place some values.
it doesn't
Correct.
have a default constructor. So
No. This class doesn't have a default constructor, so we'll
yeah,
use
that's why.
this
So
only.
whenever we will create an instance, this constructor will get called.
Yeah, but if you create default constructor here, don't you think it will break your immutability? It will break your immutability, right? You might be able to access the same map and add more values to it. So that is
Yes,
why
yes,
we
that's the
have not
reason. Yep,
created.
that's not there.
Yes, that is why I've not written here. Okay, so coming to this, so if you observe over here, whenever we create object of student class, this student constructor will be called. It is a all args constructor. It takes all the arguments, name, roll number, map, and it takes this map and it doesn't simply adds this map directly over here. It takes this map internally. This is called deep copy. Okay, this is called deep copy. We have created one more map on line number 14. If you see temporary map, and we are moving all the values from this map to the temporary map, and then we are setting that temporary map over here. Why we have done this is because, let's say anybody creates this get metadata method and they try to access this same map which was sent. So this will ensure that the map, even if they are trying to break the immutability, they will not be able to break the immutability, because this map is a different map which is set over here. So this is like we have copied the original map and given it a new temporary map which is not accessible outside, and we have assigned that to the object of student. You'll better understand it with this example. Okay, so here you can see, like, first I'm creating a map. Okay, I'm putting values 1 first, 2 second. This is the student object. I'm passing the this is what, let's see, student name as ABC and roll number as 101, and I'm passing the map. So when I'll call this map, if you observe over here, it will take this metadata and it will copy everything from this to the temporary map, and it will assign this temporary map to this metadata. So the student object will have what? It will have a new map, right? This will have a new map which is non-accessible outside over here. Now, if you try to break the immutability, okay, now let's say I've created the object, I'm getting the name, roll number, metadata, it will work fine. Now, let's say if I try to add something over here to this map, will it modify the map which is of student, or will it not modify? Or if it will not modify, why it will not modify? What have we done different?
It won't modify actually.
Yeah, because we have copied the
Yeah,
original map.
you're
And
creating a deep copy, so you don't have the reference. You're not.
yes,
Uh,
yes, absolutely. Yes. So this is what I want others also to understand. Like, we are not using the original past map for the student object that is created. We are doing a deep copy over here. We are taking this original map, copying all the content to a temporary map, and assigning that to the metadata object of the student class that is finally created. So that is why we have done all of this inside the constructor. And that is why we have not created a default constructor, because if we have default constructor, this would be accessible, and then someone might modify it and break your immutability. So if I run this, what will be the output? Can anyone tell me what will be the output of this program? So what will be the values in the map if I run it?
First and second, 1, 2, first and second. What you are
ABC
thinking?
101 and then map value.
What is that get metadata method? What it is supposed to
It
do?
returns you map, the simple map that we have created here, but not the same map. Why it's not returning the same map? Because we have copied the original map and created another map and assigned that map, and we don't have reference to this inner map in this other class. This is called deep copy. When I'll teach you about the prototype design pattern, there I'm going to dive deep into the
So it will print only 1 and 2, first and second.
Yes, it will print that only. Because when you try to even add this, it is adding to this map, but not to the map which is inside the student. Although you have passed this map over here, it is not directly using this map. It is copying this map into a new map and assigning that new map to the student object. So that is why student will remain immutable. So if I run this, you'll see like we have this only. This ABC 101. And even if I try to do this get meta, it is always returning me the same map, which is this 1 equal to first, 2 equal to second. And it is not putting these values. See, you are not getting over here 3 equal to third. So if I remove the deep copy, what will happen then? If I remove this deep copy, what will happen? Let's say, let me just copy it, paste it, and let me just get rid of this. And if I do this, will this now break the immutability?
Yes.
Yes, correct. So if you don't do this deep copy, you'll see that it breaks the immutability. But again, in this get method, it's not able to break the immutability. Reason being, I've added a check in the get one also. Let me see here. Yeah, get metadata. So here again, I've made this smart move. I've created a temporary map, new map. And what I'm doing is like whenever they do this get map, I'm copying the original map content into a new map and provide and returning the new map, and not the original map reference. So is this clear?
Yes.
How we are protecting the immutability? So for protecting the immutability, you should add these. You should make a deep copy of your all collection classes in the constructor, as well as if you are providing get methods inside the get methods also. Otherwise, it will break your immutability. So is this clear? And why have we created this final class? Why is this final? Can anyone tell me?
It should
No class can extend this class. No other
Correct.
class can extend this.
That is correct. That no other class can extend it, and if some other class extends it, they can break the immutability. Correct. They can access your your methods and variables. I mean, private they cannot access, but from the public get methods and all they can access, and they might change. Let's say they do this get name, and then if there is a set method which I have not created over here, but if there would be set method, they might assign a new name. Correct. And they'll break your immutability.
Yeah.
So you need to be very careful with the immutable class. So always ensure for creating immutable class, your classes should be final class. Your variables should be final, and create an all args constructor. Do not create a default constructor. And in your all args constructor also, if you're using any collection as a variable in your class, make a deep copy of that and return the new collection reference rather than returning the original reference. If you return the original reference, you are breaking your immutability. And if you're creating get methods on your collection class, be it any collection class, okay, map, list, or set, always return the new reference by again doing a deep copy over here. See, you can see this is a deep copy. We are taking the original map and we are copying all the contents of original map to a new map and returning the new reference and not the original reference. Never return your original reference to the calling class when you are dealing with immutable classes. So make your class immutable in this way. Always use deep copy in your all args constructor and in your get methods. So is this point clear? Is everyone clear?
Yes.
Okay. So this is
Yes,
actually
clear.
the best way of creating immutability, what I've demonstrated over here. It is completely immutable. Only I think reflection can break it. But reflection is meant for breaking things in Java. Okay. Let me close all tabs. So let's come over here. Immutable list example with core Java. Okay. So let's say this is my list and I've added this great. This is so what are the ways of creating immutable list? Obviously you can always create a deep copy, but let's say for array list, if you want to convert this array list into a immutable list, how do you do it? Deep copy is one way, but this is another way. You can create another list in this way. You can use the collections. This collection belongs to which package? Java.util collections unmodified list method. Pass your list and it will return you this immutable list. Okay. This is one way of creating immutable list. What is immutable list? Can anybody tell me that? What is an immutable list?
You cannot add any value to the list.
Yeah, so it's immutable. And immutable means non-editable. In simple words, you cannot edit it, you cannot add anything, you cannot remove anything. Okay, so this was the mutable list. Then I've converted it into immutable list with help of this collection class unmodified list method, which takes a mutable list as an argument and returns a immutable list. So this is my immutable list. Now, once I've created the immutable list, if I add learners and work hard to this list, will it print in the immutable list? Will it add that or it will not?
No.
Yeah, because when I had great over there, that time I converted my original list to an immutable list, right? So it will be immutable. It will only have word great. Let me just take it up. So you can see, okay. So great learners work hard. It is actually adding it. So if I see why is it adding it? Okay, let me see. So this is immutable list and I'm adding these values to the mutable list. So I think that is because this entire list becomes immutable over here only. If I try to use this and add value, I cannot. I mean, let's try this. This is an immutable list, right? Now what will happen? Just doing some R&D and seeing if it breaks. Yeah, see, unsupported operation exception. Once a list is made immutable, you cannot add anything to it. So it says unsupported operation exception. We have seen this, right? Immutable with core Java. So there is another way with doing with Guava jar. So I've created this Java Maven project. By the way, it's not core Java project. So Guava library had to be imported. So I've just added this dependency in the POM file. Guava, gom.google.guava, artifact Guava version 18.0. And after adding that dependency, I'm able to import the classes of that jar. So when I add that dependency and I do clean install, or that automatically Eclipse also sometimes installs it. So I get this Guava jar. So if you're using that traditional method, like going to build part, adding that library, you don't need to do that. Just use create Java Maven projects, basic projects, and you can add dependencies like this. For finding these dependencies, you need to just know the dependency name like Guava and search on Google Guava Maven, and you will go to the Maven repository. Just copy this part and paste it. Okay. Maven is not that bigger deal. It is just for managing your dependencies. Now with help of Maven, you can directly just put this simple line of code over here and just save this file, and Eclipse will download the jar, or basically this application will download the jar and place it over here in your .m2 directory. Okay, is this clear?
Yes.
Okay, so for people who don't know about Maven, just you can study a little bit about Maven. It makes your life very simple. Because let's say this is one jar that I needed, but let's say you have hundreds of jar that you need in your application, and if you go about adding those 100 jars, it can become complex, which you have added, which you have not added. But by using this, you can manage the dependencies very easily. By using this, you can even manage your transitive dependencies very easily. There are different tools for that. Obviously you can go with that traditional approach, legacy approach of Maven tree, MVN tree. But the other way I'll advise you is using IntelliJ IDEA IDE, and in that using Maven helper plugin. With that, you can very easily resolve transitive dependencies. You won't have to spend entire day to resolve it. You can do that in 10 minutes or 5 minutes with help of Maven helper plugin in IntelliJ IDE. Not in Eclipse, okay? In IntelliJ, we have that. Okay, so this is nothing but Just another way by using the Guava jar immutable list class. We are just creating an immutable list. So here is the original list. Time is too slow for those who wait. And this is this list. I'm just creating a copy of this list and placing it into an immutable list. And this immutable list belongs to this com.google.common.collection. So Guava jar. And when I add this, it's too slow. Is too slow for those who wait. Now, do you think it will print everything? Time is too slow for those who wait, or it will only print time? This is more better, I'm telling you, than core Java. Hey, this is not saved. Let me save it. So, will this? What will it print? Can anyone tell me?
It prints completely
Completely.
because
No,
it is doing a copy.
no, actually, it only prints time. Because that is why I told you here, here like what we did over here. Okay, this, let's try this over there also. Let's see how good is this utility. But yeah, I think this case will not work because this is a separate class itself. So see, if you use this, you won't have that core Java problem where some legend developer will come and write this line of a code and break it. So if you use immutable, even legends cannot break it. Correct? You see this? But for this, you cannot do this in core Java. You need to add that dependency, Guava dependency. You need to have a Java Maven project, or you need to have that jar and upload that jar to your class path. So is this clear? So I'll just wind up with these things. Can max stretch for next 7 minutes. So I'll quickly walk you through this comparable thing. So comparable is used for sorting out. So the student implements comparable. It has 3 fields: roll number, name, age, all args constructor, no getter, no setter, and this compare to. Okay. And when you implement this, you have to provide implementation of compare to. And this is the way you have to provide implementation of it. You have to write exactly this way. Then what happens is when you write it in this way, it you can pass the object, or you can pass the collection of student to a collections.sort method. Okay, collections.sort method. So here I have array list of student. I've added 3 students to it: Vijay, Ajay, Jay, and I want to sort them by what? I want to sort them by the natural order. Let's see by what we have sorted over here. So I want to sort them by age. Okay. So I want to sort them by age. So I'd simply pass it to collections.sort. It will sort it by age and it will print the output. So see, 21, 23, 27, like Jai, Vijay, Ajay. So comparable is used when you want to sort by one field. Okay. And for natural order of sorting. Comparator is used when you want to sort by multiple fields. Let's say I want to create one age comparator, name comparator. That time we use this. In the age comparator, again, the code is very similar, what you have seen over there. Just the method name over there was compare to. Here the method name was compare to. Here the method name is compare. Okay. And the code is that same only, kind of. This is age comparator coming to name comparator. Let me just format this. And here again, it is very similar code. For string, you have to write it in this way. And for integer, you have to write it in this way. You have to follow this similar way. Okay. If you, whenever you want to do the sorting, just refer this code. For integer, write it in this way. For string, write it in this way. This is your simple student class with your variables and all args constructor, and this is your comparator example, and this is your this array list of students where we have 3 students. First we'll sort it by name and we'll print it, then we'll sort it by age and we'll print it. Let me run this. See, sorted by name, it is A, J, and V. Sorted by age, 21, 23, 27. Okay. Now coming to the R&D package, let me show you something related to sorting first. Let's say I want to sort it first by name and then by age. So with comparator, you cannot directly do that, right? So for that, you have to write this kind of a code. Okay. You have to create this comparator in this way. It's not that straightforward. It is little complex, I know. So you have to write the code in this manner. So this is a very tricky concept or tricky code. You might not find it on any online tutorials or anywhere. You might find this kind of a code on Stack Overflow forums, where people have these kinds of doubts, like they want to sort it by 2 fields. So this comparator example was sorting either by age or either by name, right? And this compare method is sorting by both, first by name and then by age. So see, so here I've printed the output. So here again I've created a list of students. Now you can see Ajay is 2 times. One is 28, one is 27. So sorting by names means what? Ajay will come first. It starts with A, right? And after sorting by name, it sorts by age. So sorts by age means what? The smaller Ajay should come first and then the bigger Ajay in age. Elder Ajay in age, right? So younger Ajay is first, then the elder Ajay is there, and so on. So is this clear? Guys, is this clear?
Yes.
Yes, yes.
Okay. So I'll quickly upload this code. I'll advise you to go through this code because we had to run up in the R&D part. Yeah, this last thing is this inner class. So just to make your life more complex, I had created one inner class. Let's say this is my outer class. Inside this I have this class A, where I have a constructor which says first inner class A. Inside this class, okay, this is this is a constructor. Inside this class I have another inner class. So this B class is inner class. The most outer classes, let's see, many inner classes, and the immediate outer class is class A. Okay, so how you can access it, I've just provided an example over here. Create an reference of outer class dot inner class, and create the object of the inner class A. Using the object of the inner class A, you can create the object of the more inner class B. Okay, this is a little complex example, you can go through it. All right. Okay, so thank you for attending this session.